Acid-base titration is an analytical method in which a chemist uses a standard solution, which is a solution that we do know the concentration of, to help us determine the concentration of a solution that we don't know the concentration of. Now, in order to do this, since it's an acid-base titration, we have to find the point of neutralization, or whenever the exact amount of acid is equal to the exact amount of base. And so to help us with that, we use what's called an acid-base indicator. And an acid-base indicator is just a chemical that changes colors at different pHs. Let's take a look at an example question using acid-base indicators. In our table up here, we have a list of acid-base indicators. We have the approximate pH range that they change color at, as well as what their color changes are going to be. So our question asks us which indicator would appear to be blue in a solution with a hydrogen ion concentration of 1 × 10⁻⁶ molar. So the first thing that we can do is we can get rid of any acid-base indicators that don't turn blue. So if we look at our chart, we see that methyl orange only changes from red to yellow, so that's not going to be our correct answer. Bromoethyl blue does change blue, so we can leave that one. Phenolphthalein only changes either colorless or pink, so that one can also be dismissed. And then the rest of them all turn blue. The next thing we need to look at is our chart just gives us pH ranges. So we need to figure out what is the pH of this solution. Well, they told us that the hydrogen ion concentration is 1 × 10⁻⁶. And we know that to calculate pH, we just take the negative log of that concentration of H+. We're in luck since this one is a 1 × 10⁻⁶ and has a 1 at the beginning. We can use the little trick that we learned, and so the pH is just going to be equal to the exponent, which is 6. So now we need to figure out which one of these is going to be blue at a pH of 6. Well, when you're looking at the pH range, the lower end pH and below that is going to be the first color, and then the higher end pH and above that is going to be the second color. So bromoethyl blue at pH of 6 is going to be yellow. So that one can also be gotten rid of. Okay, litmus, pH of 6 is going to be around this lower number, so that one is going to be red. So that is not going to be correct either. Bromocresol green, a pH of 6 is going to be above the highest number, and we see that at the top of this range, it is going to be blue. So bromocresol green is going to be our answer. Now let's take a look at a setup of a titration. So here we have the setup. Here we have our burette that contains our base that has the known concentration of it. And then in our flask here, we have our acid of unknown concentration. And so what we do is we run some of our base down into the acid until we get a color change from our acid-base indicator telling us that we have neutralized all of the acid in our solution. And then from those calculations, from those volumes and concentrations, we can figure out the concentration of our acid. Let's take a look at a couple of examples. Now, for this class, we're only going to do what are called one-to-one titrations. And what that means is that all of our acids and bases are going to react in a 1-to-1 ratio. So our first one says 15 milliliters of 0.5 molar sodium hydroxide and 25 milliliters of vinegar of unknown concentration are titrated. What is the molarity of the vinegar solution? So since all we're going to be doing is one-to-one titrations, we can use a special formula to help us here. And that's going to be this formula right here. It is a variation of the dilution formula that we talked about earlier, except for this time, instead of 1s and 2s, we're using A's and B's. On this side, we have the A's. The A's are going to stand for your acid. And on this side, we're going to have the B's. The B's are going to stand for your base. Okay, so first thing we need to do is pick out which ones are acids and which one is a base. So our acid, remember, always starts with H, and so that's going to be the vinegar. So the vinegar is going to be the acid. Our bases always end in OH, so that's going to be the NaOH. Okay, so now we'll start plugging in, right? So the molarity of the acid, that is what we're looking for, so we don't know what that is. We'll put that as an X. The volume of our acid was the 25 milliliters. The molarity of our base is 0.5 molar, and the volume of that base is 15 milliliters. Now that we have everything plugged in, we can solve for X. So the molarity of our acid is going to be about 0.3 molar. Pause the video and practice this example on your own. Now let's take a look at this example. What volume of 0.2 molar hydrochloric acid solution is needed to just neutralize 48 milliliters of 0.1 molar sodium hydroxide solution? Okay, so again, all we're doing in this class is one-to-ones, so we can use our MAVA equals MBVB formula. Again, let's figure out which one is the acid and which one is the base. Okay, so this one tells us that we have hydrochloric acid, so that's obviously going to be the acid. And we have sodium hydroxide, which is going to be the base. So the molarity of my acid is the 0.2 molar. The volume of the acid is what we're looking for because it's asking us what volume of that acid. The molarity of the base is the 0.1 molar. And the volume of the base is going to be 48 milliliters. So we'll plug in our values and solve for X. And so we see that it's going to take about 24 milliliters of our acid to neutralize that amount of base.